Solve by elimination. 2x plus 5y equals 11, and negative 4x plus 3y equals 17. This is another problem where substitution is going to be a fair bit of work because each of the variables has a coefficient, and to isolate any of those we would have to divide by the coefficient, which would give us fractions. So we want to use elimination. But we can't use elimination in the same way that we've been doing, because if we stack them up and add them together, nothing's going to cancel. Let's give it a try. We've got 2x plus 5y equals 11, and negative 4x plus 3y equals 17. And if we add those two equations together, 2x plus negative 4x is negative 2x, 5y plus 3y is positive 8y, and 11 plus 17 is 28. And unfortunately, neither of the variables were eliminated, so we are stuck. So that wasn't the right thing to do. Now, we're still going to use elimination, but we have to do things a little bit differently. Let's focus on the fact that neither of the variables was eliminated in this situation. Now, to get one of the variables to be eliminated, we need the two terms to be opposites. So if we have this 5y here, we would have needed a negative 5y for the y's to cancel. Or for this 3y down here, we would have needed the top one to be negative 3y to cancel. We need the two terms with the same variable to be opposites so that when we try to add them together, they cancel. Now if we look at the x's here, this bottom x is a negative 4x. So if we want the x's to cancel, the top one would have to be positive 4x. And in this case, we can make that happen. If we have a 2x, we can turn it into a 4x by multiplying by 2. But we know that with an equation, if we multiply one thing by 2, we have to multiply both sides by 2. The rule says that we can get an equivalent equation if we multiply both sides by the same number. So that's what we're going to do. Over here, we're going to take 2x plus 5y equals 11, and we're going to multiply both sides by 2. If we distribute the 2 on the left, that's going to give us 4x plus 10y, and on the right, 11 times 2 is 22. And now we can stack this equation along with the other one, negative 4x plus 3y equals 17, and when we add them, we will get some cancellation. The difference here is that we have two terms that are opposites. 4x and negative 4x are opposites, so when we add them together, they're going to cancel out. That's why we had to multiply by 2, so that we could have a 4x to cancel out with the negative 4x. Let's keep going. If we look at the y's, 10y plus 3y is 13y. And then on the right-hand side, if we add the constant terms, 22 plus 17 is 39. So we have 13y equals 39. And we can get y alone by dividing both sides by 13. If we do that, 39 divided by 13 is 3. And so we end up with y equals 3. But we're not finished yet because we still have to solve for x. Now, whenever we have the value of one variable, we can plug it into any of the equations that contain both variables to solve for the other. So we could pick 2x plus 5y equals 11, or negative 4x plus 3y equals 17, or even positive 4x plus 10y equals 22. We can pick any of them. I'm going to pick the first one, 2x plus 5y equals 11, because it doesn't have any negative coefficients, and the coefficients are small, so it's a little bit easier to manage. We figured out that y is 3, so we're going to substitute in 3 for y in that equation. When we multiply, 5 times 3 is 15, so this becomes 2x plus 15 equals 11. If we subtract 15 from both sides of the equation, This gives us 2x on the left and negative 4 on the right. 11 minus 15 is negative 4. And then to solve for x, we divide by 2, which gives us x equals negative 2. So we have our final answer, x equals negative 2 and y equals 3.